In this section, we're going to look at the addition and multiplication properties of equality and how to use them together to solve multi-step equations. So the first two examples we're going to look at in topic one, they're pretty okay. And then in topic two, the next video, we'll look at just general, like kind of like a general set of steps that you can use to solve really any multi-step equation. Okay? So for topic one, it just says using the properties together. So remember the addition property of equality, that allows you to add and subtract on each side of the equation, okay? The multiplication property of equality allows you to multiply or divide each side of the equation, okay? So when we use these properties together, we want to simplify each side of the equation. So simplify the left, simplify the right. And kind of what we mean by that is you want at most two terms. One variable term, one constant term. Okay. So when we simplify, we're just trying to get it down to the most manageable state possible. So you want to combine all like terms on the left and then separately combine all like terms on the right. We want at most two terms on each side before we start adding and multiplying. Okay. So once we simplify each side of the equation, we then want to apply the addition property of equality. The goal here is to get your variable term on one side of the equation and your constants on the other, okay? So after we simplify the left and the right, we want to get all the variables on one side, all of the constants on the other side. And then finally, that puts us in a position where we can use the multiplication property of equality to finish solving the equation. So the first example I gave you all is just a really basic solve this two-step equation, okay? We're not going to have to simplify on the left or the right or anything like that. In part B, we will, okay? Now, for example, one, it says solve each equation, and this one does say check your solution. So depending on the directions, we'll check some solutions, we won't check some solutions, even if the directions say check them always, okay? Just know that you always can check them, but just for the sake of time and the length of the video, we may or may not check every single solution, okay? So for part A here, we have 3x minus 12 equals 0, okay? This is as simple as you're going to get. Notice on the left-hand side of the equation, we have two terms. One is a variable term, one is a constant term. And then on the right-hand side of the equation, we have one term, which is a constant, okay? So when you have a situation like that, you can automatically start using the multiplication and addition properties. You start with addition first, then multiplication second. So in this particular case, remember, our goal is to isolate the variable, okay? So we're always playing this game of undoing what has happened to the variable. Well, what has happened to this variable x? It's been multiplied by 3, and then we've subtracted a 12. Well, let's start by getting just the 3x alone. So you want to isolate the term that contains the variable first, and then you can do the multiplication property of equality. So we're going to address the 12. Okay, so in order to move negative 12 or minus 12, we want to do the opposite operation. Well, the opposite operation of subtraction is addition. So I'm going to add 12. But here's the deal. If you add on one side of the equation, you must add on the other side of the equation. We have to maintain that balance that comes naturally with these equations. So when we start applying these two properties, whatever we do to the left, we have to mimic on the right. Now, on the left, when we subtract, when we take this minus 12 and then we add 12, they just become 0, okay? So as mathematicians, you'll hear us all the time say, hey, these 12s cancel. Sure, they cancel, but you need to really understand why they cancel. Negative 12 plus 12 is equal to 0. So when we take 3x and we add 0 to it, nothing really happens. So we can say, hey, the 12s cancel, but they really just become 0. So we're left with 3x equals, and then 0 plus 12 is 12. Okay. Now we've got the 3x all by itself. We've got the constant term all by itself on separate sides of the equation. This is when we can officially apply the multiplication property of equality. We want to get the x by itself. We currently have the x term by itself. Now we want to get the actual x factor all along. So what has happened to x? It has been multiplied by 3. And in math, to undo multiplication, we divide. So I'm going to divide the left by 3. But to maintain that equality, I have to also divide the right by 3. Okay? So over here on the left, we have 3 divided by 3. So 3 divided by 3, they just divide out to become 1s. Okay. And then 1 times x is x. So this is another situation where we'll get lazy in math and we'll be like, oh, the threes cancel. It is totally appropriate to say the threes cancel, but you have to know why the threes cancel. The threes cancel because 3 divided by 3 is 1, and 1 times x is just x. Okay. And then on the right, we get 12 divided by 3 is 4. So this is our solution, x equals 4, but the directions here say check. So we're going to go ahead and check this one because it'll be pretty quick. So if you want to check your solution, you basically evaluate both sides of the equation for whatever x value you're considering. And then if you get a true statement, you've got the solution. If you do not get a true statement, you have a value that is not the solution. So we have 3 times x, which is really, we have 3 times x, which is really 4, minus 12 equals 0. We want to see if this is a true statement when we evaluate for x. Well, we have to start just using the order of operations. So on the left, we would have to multiply first. So 3 times 4 is 12. 12 minus 12 is 0, and 0 equals 0. So we can say with confidence, this is our solution. So the solution to this equation really is 4. And you'll see x equals 4, which is perfectly appropriate, but sometimes you'll see this written a little bit fancier, a little bit more formally, and it's called set notation, okay, or solution set notation. And you'll just use curly braces, and then all you do is put the solution inside, not the x equals, just the number itself. So you could see either of these notations. So just know they're both the same thing, okay? I, again, am perfectly okay here, but just understand that these two things say the same thing. They're saying the solution to this equation is the value 4, okay? Now, part B, we've got to do more work. You can see just looking at a glance, part B is more involved, okay? So we do need to start simplifying. And when we say simplify each side of the equation, we generally mean like start combining like terms, okay? So over here, we're on part B, we're going to start on the left-hand side. I have 19x minus 7x. Those are like terms. They have matching variable parts. So let's simplify 19x minus 17x. So 19x minus just plain 7x, excuse me. So 19x minus 7x. We want to take 19 minus 7, which is 12, and then just keep the x. And so that kind of takes care of the two x terms, and then we still have minus 2. So we get minus 2 equals. And then on the right-hand side, we have one variable term. That's just this plus 6x. So I'm going to go ahead and write plus 6x. And then we have two constant terms that can be combined. We have 31 minus 15. So take care of 31 minus 15. You can type that into your calculator if you need to, but 31 minus 15 should give us 16. Okay, so this is as simple as it's going to get at this point. So when we say simplify the left, simplify the right, we want to get to this stage right here, where each side of the equation has at most two terms, one variable term, one constant term. Okay, so if you look at the left, we have one variable term in 12x, we have one constant in -2 or -2. On the right, we have one variable 2 in 6x, and we have one constant term in 16. Okay, so this is when we start moving stuff around. The easiest way to think of this is students will start moving terms around way too soon, and they move too many times. You want to apply the addition property of equality at most twice. Okay, so think of it as you're moving homes. Okay, are you going to move your kitchen one fork at a time, or are you going to pack up all of your silverware into one box and move your silverware all at once? Of course, you're going to move your silverware all at once. Same thing with your dishes. You're not going to move one plate at a time from the old house to the new house. You're going to pack up all of your plates and you're going to move your plates in one big box to the new house all at once. It's sort of the same thing. We don't want to move terms from one location to the next until we've got all of the same type of term packed up. Okay, so that's what the combining like terms does. Okay, we're at a point now where we can start moving stuff from one place to the next. Okay, so we want to get all of our variables on one side of the equation. We want to get all of our constants on the other side of the equation. Typically speaking, we start with the variables and we move them to the left. That is not set in stone. That does not always have to happen, but that's just typically what we do. Okay, so I'm going to go ahead and look at this 6x first. I want to move 6x to the left. Okay, well, 6x is positive, so we could think of that as plus 6x. Okay, how would we move something with addition? Well, we would subtract it. That'll undo addition. So I'm going to subtract 6x from each side of my equation. On the left, I have 12x minus 6x, which is just 6x. And then I still have a minus 2, so I'm going to drop it down. And then on the right, 6x minus 6x is just 0. And then 0 plus 16 is just 16. Okay? So I've got 6x minus 2 equals 16. I need to address this minus 2 that is on the left. I want to get all of my variables on one side. That has happened. We've got all of our variables on the left-hand side. We want all of our constants on the other side. So I need to scoot this minus 2 to the right. I do that with addition. The opposite of subtraction is addition. So negative 2 plus 2, that's just 0, or minus 2 plus 2 is 0, which leaves me with just a 6x. And then 16 plus 2 is 18. Okay, now we finally have one term on each side. The left is a single variable term, the right is a single constant term. We want to go ahead and officially solve for x. We want to get the x alone. This means we're going to apply the multiplication property of equality. We need to undo the multiplication of 6 and x. So to undo that multiplication, we would divide. So if I divide by the coefficient of x on the left, I must divide by the coefficient on the right. Okay? 6 divided by 6 on the left. Well, 6 divided by 6 is just 1. 6 goes into 6 one time, and I'm left with x. And then on the right, 18 divided by 6 is 3. Okay? Now, I'm a little tiny bit scrunched for space here, but the directions do say to check. So for this one, I do want to make sure that you really understand how to check your solution. So we'll check again. So I've got 19x, which is really 3, minus 2 minus 7x, which is really 3, equals 31 plus 6x. Remember, x is really 3, minus 15. I know this is a little scrunch. Sorry about that. Okay, so let's see. 19 times 3, that's going to be 60 minus 3. I think that's 57 minus 2. And then 7 times 3 is 21, so we're going to go minus 21 equals 31. Plus 6 times 3 is 18, minus 15. On the left, we want to do all of our subtraction. So let's see, 57 minus 2 is 55. 55 minus 21 is going to be 34, I think. So let's just double check. We'll use the calculator. So 57 minus 2 minus 21, it is 34. Now we want to make sure we get the same thing on the right-hand side. So let's see, 31 plus 18 is going to be 51 minus 2. So it's going to be like 49 minus 15 would be, I think, 34 again. Let's double check. So 31 plus 18 minus 15 is 34. Everything really does check out. When we plug in x equals 3 into the original equation, we get a true statement. The left really does equal the right. So we can say that our solution is confidently x equals 3. And remember, you could also write it kind of in that formal solution set notation where we use the curly braces, and then you just put the value for x inside. Okay, so that is using the two properties together. Just remember, the name of this game is to maintain balance. Whatever you do to the left, do to the right when it comes to applying these properties, but you don't want to apply these properties until you get the left and right as simplified as you possibly can. So that means combine like terms, do whatever you need to do to simplify the left and right. You want at most 2 terms on the left, at most 2 terms on the right, and then start applying these properties. Okay, so I think the next example we're going to look at, and the next one we're going to look at, okay, what do you do if you have parentheses as well? Okay.